After doing that common sense part, now go for the accurate calculation. Strongly I encourage you, before you do anything on the calculation of this challenge, draw the cash flow. Here is the cash flow for this challenge, and you notice now, like a leverage that help muscle to become even thousands of times more stronger, this cash flow do the same thing. Because now we can see everything. Okay, here are the 9,000 yearly payment for 4 years at the beginning. 1, 2, 3, 4. Here is graduation. That for the graduation year, Maria has received the payment. And after graduation, at the end of year 5, she needs to start paying off her loan in 5 payments, 5 consecutive annual payment. And for this part, the loan start calculating the interest rate. Don't forget amortization table. That provided you with the foundation logic you need to do any calculation. Before you stop the video and start working on this challenge, I want to give you some heads up to not do those mistakes, because some students immediately start for doing this problem with IRR. You cannot do that, because you don't have A here, and you need that. And here, some students do not consider the fact that there is no interest rate here. So what do I mean as those heads up, that 2 heads up that I'm giving you? So I want you to go faster to the part that you can handle this challenge, especially the fact that here there is no interest rate, my friend. So when there is no interest rate, it would be way easier to do the calculations. Don't overcomplicate it. So 2 points I just told you. Since you don't have A here, you cannot run an IRR here. Because you need all the cash flow to be able to calculate the IRR. Another thing, pay attention in this area, in this period, 0 interest rate. Okay, now stop the video and try your best. Okay, the answer here. When we want to calculate this A, I'm not gonna overcomplicate it for myself. $9,000 here. They have told Maria that we don't charge you any interest rate until graduation. Okay. So very easily Maria can transfer this to this time when there is no interest rate. So take all these values to here. So Maria can simplify her loan issue, her loan case, to this case. He is getting $36,000 at the end of year 4. Somebody should say, no, they paid him $9,000 4 years ago, and $9,000 4 years ago has way more value than $9,000 now. No problem, it's not our problem. Because they have said that they are not charging her interest rate. So $9,000 4 years ago is the same as $9,000 now. $9,000 3 years ago is the same as $9,000 now. $9,000 2 years ago is the same as $9,000 now. So totally we have $36,000 at the end of year 4. We have received that. Isn't it super simple case now for you? That's it. So go ahead. And if now you discovered how to move forward, and now it is revealed to you how you should do it, just stop the video, and as I have always told you, be greedy regarding doing things yourself. Every cell of our body has memory. And anything you do, it's gonna be somewhere safe, and it comes to save you at the best time somewhere. So be greedy regarding doing things yourself when you are in the phase of training and you have time. Okay, here is the formula. Hey Excel, calculate it for me. The rate is 5%. It was in the question. It was in the case description. 5 years. And the present value is 36,000. Here you go. So she needs to pay $8,315 per year. Another thing, the next step, it is asking us to calculate internal rate of return. Okay. I'm going to use that block function, IRR, and here I'm going to put, these are the years. So it is the simulation of the things that you see. 9,000, 9,000, and here are the payments that I just calculated, and here the formula for IRR. And it says 2.66. And now you can check the answer that you gave about that common sense part. When you are getting a loan, that's almost half of the loan is with interest 0, and another half of the loan is 5%. So what is the total interest of the loan? Yeah, it should be, of course, less than 5%, because half of the loan doesn't charge me any interest, and half 5%. So for sure it brings it down. Okay, so problem solved, and I'm showing you another way of doing this challenge. And you know, we are always go for the easiest way. So the first one that I showed you just in the Excel is my recommended way of doing the challenge, but here it is also a smart way of doing it. 9,000 times 4, so everything comes here. 36,000, and here it says that give me, now I'm giving you the P is 36,000, give me the A. Here is the answer. And after that, for calculating the internal rate of return, It puts all the cash flow and use net present worth approach. And after that, doing that interpolation to come up with this answer. And here you see again, this making it find the interest rate that makes everything 0 is the point. And since we already have the equivalent uniform payments, revenue, savings, so it goes for transferring them into present value because we already have that annual payments, annual income. So we want to get P. And okay, that's it for this beautiful question. Another example on bonds. A corporate initially sold its bond $1,000. That's the face value. That's gonna change based on the interest rate of market. Issuer will pay $40 interest every 6 months. And as the routine, it is committed to repay that $1,000 face value after 10 years. Now, it wants you to calculate the investment rate of return for this bond if just after 1 year the owner wants to sell it, but now the market value is $950. Why the value of the bond dropped just after 1 year? Most probably because the market interest rate has increased. So this bond has become less attractive to the investors. So they are going to pay less amount on that. So now in this challenge, you are going to see what would be the interest rate in this situation, what would be the internal rate of return in this situation. And it wants to give you that confidence that when you have that good understanding of this field and you get this skill, you can calculate the interest rate dynamically at any point when you are fed with the data necessary to do that. Okay, go ahead and do that. And don't forget, as I have always said, draw the cash flow first. It really works like a leverage for your brain. I do the cash flow first here, and since it is being sold after just 1 year, so the cash flow would be small. Now they are paying $1,000 face value of the bond. After 6 months, they get the interest of $40 according to the contract, and it is the definition of bonds. After another 6 months, they get their $40, correct? But also they want to sell the bond for how much? $950. So it would be the total cash flow. And you run the IRR function on this cash flow to get this result. So IRR and this. So what is the interest rate on this bond? We are going to say 1.52%. Okay. Now I have a question. When somebody asks about the interest rate, they want to know about the annual interest rate. But my question is this from you now. But I'm saying that my question is this from you now. So it means that just get involved and try to answer it. And if you cannot come as fast as the video goes, just stop it, think about it, and answer it. Make sure you become a composer. Make sure you develop your own idea about these questions that I'm putting forward. So 1.52, is it annual that you just calculated? No, it is not annual. We just calculated the IRR for this case. And for this case, the steps, the gaps between two consecutive payment or event is 6 months. So this 1.52% is for 6 months. So what if I want the annual one? Okay. This times 2. So it is the annual. Now I'm asking you, is it real annual interest rate? And I'm talking about these things for the first time. So it is not a review. Is it really 3.05%? No, it is not real. It is nominal. Okay. So on the bonds, they said that we are paying you the nominal interest rate for these bonds are 3.04%. And now you know about the logic, how to calculate all these things. And they pay, in fact, biannually, every 6 months, at the real rate of 1.52. Now the question for the first time. So if someone asks you, what is the real interest rate of that annually? 1.52% cannot work because it is for 6 months. 3.04% does not work because it is nominal. It is asking you about the real. Okay, let's do it together. When we want to calculate the real, we have learned that after 6 months, our $1 becomes this much. I guess I'm overcomplicated with this percentage. So let's make it number. Okay, now it's better. So it means that after 6 months, our $1 become $1.0152. Okay, now go for the compound interest that we discussed before. Because it is paying you after 6 months, for the next 6 months, you can consider compound interest, not for the bond, but it means that when you get this interest rate, this interest that is 1 cent and something, you can go and invest it somewhere else. So you see, the reality is different. If I want to put it into word for you better, the bond is giving you every 6 months the interest. After the first 6 months, you get the interest in comparison to the times that a bond gives you after 1 year. And they both say their annual interest rate is 3.04. But for the first one, since it is giving you after 6 months, it pays you X dollar. Okay, you can go and take this X dollar and invest it again. So the effective interest rate is higher than this one. We are going to talk about this. I just opened the idea. Okay, so now let's go here for the calculation. So we got it because we did these calculations for compound interest. So after 6 months, our money become this much. And now we can invest that money again for another 6 months. Just remember compound interest we discussed before. So after 1 year, you have this much money. You may ask, what about the third period? Just continue this. This 1 plus is a regular thing. But what makes it different? Because now this 1 plus this also being applied to the interest you are receiving. So your money is this. So what is the rate of return after 1 year? So the interest rate, the real annual interest rate is a little bit higher than this. But still, it is higher. That is exactly 2 over 10,000 because the difference between these two things is 0.02%, that equals 2 over 10,000. Okay, and here you can see another way of writing everything. Here is the cash flow and calculation of the interest rate. We didn't have any problem regarding that part. Just for the first time, we are talking about the effective interest rate. That is some sort of practical thing, and don't try to overcomplicate, or we are going to practice more and more on this type of thing. And when you calculate the nominal one, this times 3%, and when you are working on the effective one, go with the compound interest. Also pay interest over the interest you are receiving, and so it is the results.